Welcome to Energy Unplugged, the go-to podcast focused on the energy transition. My name is Marc Hedin, Head of Research for UK and Ireland at Aura. And my guest on the show today is Toby Edmonds, Executive Vice President for Offshore Renewables at Northland Power. Prior to Northland Power, you had the position of Chief Operation Officer at Maple Power, a company developing wind assets in France, Germany, and the UK. And before that, you had a number of senior positions at RWE, also looking at wind products. Toby, welcome to Podcast Booth.
Hello, nice to be here. Thanks for inviting me.
Toby, you've had an extensive career in the energy industry, spanning over 2 decades, with a strong focus on offshore wind over the past 15 years. How would you reflect on progress made to date? I'm thinking mostly how far we've gone with fixed bottom offshore wind, and where on that curve we are with floating offshore wind.
Sure. So, I've been very fortunate to be involved with offshore wind really since the beginning here in the UK where I'm based. So I was originally involved as the general manager of a project called North Oil, which was the first commercial scale project in the UK, built in 2004. That was the start. And of course, where we are today is there's more than 40 projects here in the UK with a total capacity of over 14 gigawatts. And if you'd asked me at the beginning if we were going to end up here, I wouldn't have expected such an amazing growth in that time. I mean, since I got involved, we started with 2 megawatt turbines, and they've now grown to 15 megawatts in that period. And blades that you see on the turbines have gone from 50 meters to over 100. So a massive increase in scale has characterized my time within the industry. I've been very fortunate to be, as I say, involved in that first project, but leading on from there, got into the construction side of 2 big projects in the UK, one off the north coast of Wales called Gwynt, which was 576 megawatts. At the time, second largest offshore wind farm in the world, but by today's standards, pretty small. And then I moved to the east coast of the UK with a project called Galloper. On that project, we went from a 3.6 turbine from Siemens to a 6 megawatt turbine from Siemens. And now, as I say, we find ourselves in a world of 15 megawatt turbines. I've been involved personally in 20 different projects now, in one way or another, whether that's as an operator or as a project director. And I can tell you from experience that whilst they may, from the outside, appear kind of similar, they all have some really interesting and unique differences. And I think the thing that's really characterized, my involvement has just been a real sense of enjoyment of being involved in construction and seeing these projects go from the desktop, from the computer, into reality offshore is quite remarkable and an amazing thing where you see hundreds of people from all over the world and many, many companies getting involved in one project and coming together to deliver it.
A very fascinating journey. And today you lead the offshore wind side of the business at Northland Power, which is a Canadian independent power producer, investing globally across clean technologies. What's your take on the position of offshore wind within the portfolio of Northland Power?
So, as you say, Northland Power is a Canadian company. It's an interesting company because it's involved in not just one technology, but several. It began in the late 80s in gas-fired generation and biomass, and moved fairly promptly in the 90s into onshore wind, and it continued its journey in onshore wind today, where in America it's even got 3 projects in the US as well as some in Canada. Interestingly, Northland also is building a battery storage plant, a 250 megawatt, 1,000 megawatt hour project. So a pretty big battery in Canada called Oneida, and it's the first utility scale battery in that market. So those are some of the other things that Northland has been doing in the generation world, as well as offshore wind, which it got involved in 2014 when it bought into the Gemini projects in the Netherlands. Since then, they've added 2 projects to the portfolio, Nordsee 1 in Germany, 332 megawatt project, and Deutsche Bucht, another 260 megawatts. So they've got a established portfolio and now moved into construction on two mega scale projects, I would call them. The Baltic Power project, just over 1 gigawatt in Poland, and the Hailong project, a gigawatt project in Taiwan. So not just going big on projects, but going global as well, reaching into the Asian market as well as North America and Europe. So that's where we find ourselves today. I think offshore wind for Northland is just over 50% of the revenue and money that it makes. So it's a pretty important part of its portfolio, and one which it believes we believe has a strong future in the markets that we're in, and for us as a company.
And reflecting on that history of offshore wind that you've just presented, in recent years, I've noticed that wind has lost market share versus solar in global renewables investments, according to the IEA. I think IEA estimates that in 2024, there will be more money deployed in solar PV than all other generation technologies combined. Why do you think this is? And is this temporary, or is this a sustained trend?
Energy has never been a one-horse race, right? So it's always been a mix of technologies, really, just because some markets, they have different natural resources. They might have a lot of space, or they might have a lot of wind, or in the past, they might have had coal or natural gas. So it's always been a mix of technologies. I think solar is brilliant. It's certainly the cheapest form of energy. And as you may have read famously, it's now cheaper than fence panels. There's been a well-publicized case where in France, in the Netherlands and Germany, they actually found it was cheaper to build a fence out of solar panels than it was to do it out of fence panels. So no one can argue that solar is cheap, and that's why it's being deployed at such a large scale. Of course, each of the technologies has its own unique characteristics, and that can make it more or less attractive in a particular market. The obvious problem with solar is obviously what happens at night, and it also competes for the land, with agriculture as an example, and also in some places, the visual impact is a concern, certainly in sort of national parks and areas like that. So it's not the perfect solution everywhere. The great thing about offshore wind is that, of course, you can put it at sea over the horizon, so you get away from that impact on the visual impact of coastlines and communities. But the other thing about offshore wind is just its scale. Today the projects are gigawatts. We're doing 2 gigawatt plus projects ourselves. And so if you want to have rapid deployment of renewables, rapid decarbonisation, then really offshore wind is a great choice for that. But I don't really think this is a choice. We need to do all of these things, right? We need to do solar in a big way. We need to do offshore wind in a big way if we're going to meet the challenges that climate change is presenting, and the targets that our governments and indeed the people in the countries where we deploy renewables are expecting us to deliver.
Absolutely. And getting into the core of today's topic, like as you mentioned, an offshore wind project is a mega project. It's gigawatts of capacity for recent projects, billions of dollars of capex, typically over a decade from inception to commissioning. So these are really massive projects. Can you walk us through the development process of an offshore wind farm?
Sure. So, much like any kind of development project, the first thing you need to do is find a site. Where am I gonna put this project? Obviously, offshore wind, we're gonna be at sea, but then we need to consider all of the things that we need for a successful project. So we need it to be windy, we need access to the grid, and we need to be able to physically build it. And that typically with a fixed bottom offshore project, the water depth needs to be below, I would have said 80 meters a few years ago. Maybe we can push that a little bit further towards 100, but it needs to be certainly below 100 meters with today's technology. So we need to get a site. Now, in some markets, you can go and survey the sea and decide where you want to put a wind farm and actually apply to the government to do that, who typically control the seabed and the coastline around the country. Or the government itself will identify areas or even specific sites where they would like offshore winds to be deployed, and they'll run some kind of a process to auction it off. And so we may take part in one of those auctions. So that's number one, get the site. Number two, then you have to develop it. And that really means that you need to look at the site, you need to assess, importantly, the environmental impact that you might have as a result of being there. So that's considering effects on the environment, what's on the seabed, what's living in the sea, what potentially is flying above it in birds and things like that. So consider the impact there. What people probably don't know unless they've been involved in marine activities, just how busy the sea is in terms of existing telecoms connections. So, the internet crossing the globe via fiber optics. You've got oil and gas pipelines, you've got shipping lanes, you've got aggregates, people who go and collect gravel and other sands and things from the seabed. You've got shipping, everything's going on out there. So you have to take all of that into consideration when you're developing your project. And ultimately, you need to design it and say, well, this is taking all those things into account. This is what my project's going to look like. And then you need to ask for permission or consent, as we typically call it. So that's the next stage once you've kind of designed and assessed your site. So you go into consent. So you go and consult with all of the interested parties, sometimes called statutory consultees. So that might be governments, national bodies that protect landscape and the environment, and go and talk to them about it, present the information, and ultimately receive their questions and challenges, maybe adjust your design, and then end up with a proposal that you put forward for permission. So this is where you say, here's everything we've done. We've consulted with everybody, whether that's the community in which the project sits, the users of the sea, or indeed the statutory consultees that consider all aspects of the project. And then you ask for permission from the relevant authority. And then you get that if you've done your job properly. And once you've done that, you've then got the site, you've got the permission, and you've had approval to do it. Alongside this, you need to get the important thing called grid. So you need somewhere to connect your power to the grid system. And that's not easy. You have to maybe build quite a big grid connection yourself. Maybe the grid operator does it for you, but they have to find a way of connecting that to the high voltage network in the market that you're in. And that can be a lengthy process, and also that can take a long time. So you might get a grid offer, but it might be 5 years in the future. But you need that as well, so that you can connect it up. So once you've done all that, you need to think about, how am I going to get paid for it? Am I going to get a tariff from the government? So the government's going to say, right, we're prepared to pay a fixed price for green energy for the next 15 or 20 years. And you go into that kind of a process. Or you go and talk to a bunch of big customers and do what we call a PPA, or power purchase agreement. So that's going to a big petrochemical company, for example, and saying, hey, do you want to buy some green power for the next 20 years and sign a contract with a fixed pricing? And at that moment, you've got everything you need. You've got the sites, you've got the grids, you've got the permission or consent to build it, and you've got offtake, so you know how you're going to get paid for it. So at that point, you can take the whole package, typically these days, to a bunch of lenders to say, look, this is going to be really expensive. I need to borrow some money. And they'll give you or promise to give you the money, maybe 60, 70% of the money. And the rest you need to get from your owners, your equity sponsors. And once you've got all that in place, you can take what's called financial close and say, yes, we're going to build it. We're now going to place all of the contracts to build it, for the turbine, for the foundations, for the grid system. And we're ready to go. So then we spent probably a couple of years, or 1 year, maybe two, manufacturing, and then we go offshore and into construction, which probably takes between 1 and 2 years, depending on the project. Once you've done all that, you've then just got the small task of operating it for up to 30 years or more at the level that you said it would perform, which is also a lot of work.
I would like to unpack a little bit what happens before the building phase. It's kind of the immersed part of the iceberg, if I can say so, like given everything you've said, everything around engineering, planning, consenting, and grid connection. These take years. I mean, in GB, around 75% of the lead time of an offshore wind project is linked to this. Why is this so lengthy, and what are the main hurdles there?
Yeah, so I mean, partly there's just a lot to do with the projects. I mean, I touched on a couple of things, and maybe I'll just say a bit more about a few of those. I think consenting, getting the permission from all of the relevant authorities to build a wind farm does take a lot of time. I think what people may not realize is that in order to do that, we have to do a lot of data collection. So if we take impact on birds, for example, we need to do bird surveys for at least 2 seasons. So that's 2 years of bird surveys. And there's no way of shortcutting that. They want to know exactly what birds, particularly migratory birds, pass through the sites on an annual basis. And of course, there can be some variance between years, particularly in this world of climate change where things are moving around. They need 2 years of data. So we have to spend 2 years doing that, quite rightly. Also, there's a huge amount of documentation that's required in order to give the authorities all of the data that they need to make their assessment. And it runs to many, many thousands of pages on all aspects of the wind farm, things like effects on archaeology, as an example. There's lots of archaeological significant things, both offshore, if you're just doing the offshore part, but also onshore. You may have a 10, 20, 30, or even 100 kilometer onshore grid connection, and you need to not just plan that, you need to go and survey that whole site. There may be ancient ruins, as an example. Across that site, there might be ancient woodland, whatever it might be. All of that needs to be surveyed. And of course, if you have got 50 kilometers onshore cable route, then you probably have quite a few landowners that you're crossing, and you need to go and talk to all of those, take the questions, and ultimately negotiate a lease or a contract to allow you to come onto their land, bury your cables, and then leave them there for the life of the wind farm. So there's quite a lot to do. I think the other part is that once you've done all that, you then hand it over to the authorities and they need to review it. And that can often take a long time, much longer than we would like. And there's legislation that governments around the world are trying to introduce to reduce or condense that process, but it does take a long time. One of the challenges they've got, in fact, we've all got as an industry, is, of course, you need people to do these reviews. And as the industry is growing, you need more and more people. I think today, there's approximately 1 million people globally employed in offshore wind. And by the end of 2026, that needs to treble to 3 million, So, and that's not just, us as developers, that's also the regulators and consultees in these processes that need to find those people, train them, and get them up to the right level of competence to do this work. So that, again, creates some delay potentially in the process. So you've done all of this work over many years, and things take time. Then you have to present all that information, and it needs to be reviewed. And then there is an iterative process, right, where they ask questions, you give answers. I think one area where it could be improved is much clearer alignment at the beginning on what's expected at the end, because what can happen, and you see happen frequently, is that questions get asked at the end, which require the developer to go back and repeat, say, bird surveys as an example. That would add 2 years to the program like this. So those kind of things we'd obviously like to avoid. So I think consenting is one of the big areas that's just a lot of work and a lot of time, and is prone to delay, to either repeat things or do more work. The other big area is grid. Grid is, obviously essential. We can't do anything with the electrons if we can't connect them to the grid system. And so we need to do that, and they need to, the grid operator, which is typically grids in countries are operated by a monopoly provider, which is typically state-owned, but not always the case. For example, in the UK, National Grid is not state-owned, but they need to do a huge amount. If you think about, when I joined the industry at the end of the 90s, there were a small number of power stations, very large conventional power stations, coal and gas across the UK, and a relatively small number of generating units. Now you've got thousands of wind turbines, onshore, offshore, solar, as we discussed, all interacting with the grid and connecting to the grid. So it's completely changed from how it was. And if you read what National Grid in the UK is saying, they're saying in the next 7 years, they need to do 5 times the investment work that they've done in the last 30 years. So it just goes to show they've got an awful lot to do. What does that mean for us? It means that it's going to take quite a lot of time to actually decide where the grid connection should be, and also quite a lot of time for them to be ready to actually connect us to the grid. And that's why you could just get a delay that says, hey, look, you might be able to get the consenting done and everything ready by, say, 2030, but you might have to wait another 2 or 3 years for the grid connection to be available. And that's why you see this extended period.
Indeed. From listening to our clients, grid is increasingly mentioned as the number one hurdle to developing new projects. In GB, there's an impressive almost 800 gigawatt of connection queue at the moment. It's over 10 times what we actually need to build to get to a net zero economy. And I know that TSOs in GB in particular are increasingly thinking about it in terms of holistic network development plan. Is this the way forward? Does this mean that in 10 years from now, there will be enough grid connection immediately available for all new projects, or are we daydreaming?
I'm afraid you're daydreaming on that point. It would be nice, wouldn't it, if we could just immediately connect our assets to the system, no trouble at all. Of course, they are massive projects, and they do obviously require quite some adaptation of the grid to connect them. But coming back to your question, holistic network design is the way to go. The 800 gigawatts you talked about is a function of the process which they have in the UK, which means everybody, anybody can apply, and they have to give them an offer, and you end up with this kind of crazy system. So holistic network design is really looking at, as a system, where do we think what's the most likely places they're going to deploy? Offshore renewables, an example, and roughly how much do we think they're going to deploy? And based on that, what do I need to do to the whole grid system to reinforce it and create the capacity across the network to allow these schemes to connect, frankly, much quicker and allow us to decarbonize faster. So I think that is the way to go, and it's starting to happen in a number of markets, and I think that's really important. I think in parallel to that, innovation has to play a role in this because, being smarter, that grid being smarter, using whether it's AI, better demand forecasting, weather modeling, or whatsoever, to do a better job of predicting how much power we're going to get from things like the wind and the sun, and looking at demand and being clear about how much power we're going to get. And even, in a future world, maybe we can sort of turn things down automatically to manage demand, so we don't have to build quite so much capacity, because grid capacity is expensive. Copper is expensive. The rise of raw material prices over the last 5 years has been astronomical. So building these systems out of aluminium and copper is super expensive. And so if we can be smarter about the way we use them, then we can reduce the cost, which at the end of the day reduces the cost to you, me, and everybody as end users of power, whether it's to charge our car, charge our iPhone, or put the lights on.
Yeah, and you mentioned innovations, and maybe just closer to home and thinking about grid connections for offshore wind. We're seeing innovative multi-purposes interconnector projects in the North Sea, linking different countries with an offshore wind farm in the middle, like Lion Link between the UK and the Netherlands. Could this be a new way of thinking how to connect offshore wind and also increasingly connecting all the grids together and so sharing the benefits of offshore wind? Will we see more of those projects?
We definitely should. I think it's a great idea. It's frankly, it's much easier to connect two countries under the sea with a cable than it is to build a transmission line across the country, because you don't have the same visual impacts and you don't have the complexity of land ownership to deal with and all the other infrastructure that you have to cross in between. So I think it's a great idea. I mean, what it does do is it allows the power to be transferred across markets. For example, if you've got a surplus in the UK, but then in the Netherlands, for whatever reason, the wind isn't blowing just now, or some of their conventional assets aren't working, then you can transfer that power. And that's great because it means that all of those green electrons are getting used in the system. So we're offsetting and removing carbon from the system. But also it has an effect of avoiding those price spikes that you get in those moments where demand is very tight. So that reduces the overall cost of energy for the consumer as well. So I think they're a great thing. And of course, they provide more capacity in both directions. So, if the UK is short of power, it can pull more in. And if it's long power, it can sell it. So I think they're great, and we will see more. There's been a huge rise in the number of interconnectors in place. I mean, traditionally, we just had the one with France for many, many years, where we used to get the advantage of the French nuclear. Now we have a whole range of different connectors to Norway, to the Netherlands, and indeed more to France. So I think that will definitely continue.
Close to home. I'd like to explore with you the financing side of a project as well. It feels like offshore wind, which is very capex intensive and with quite long lead times, as we discussed, has become a bit harder to justify as an investment in a high interest rate environment. So my question is, how exposed is the sector to the monetary environment, and what is the direction of travel from here now that rates seem to be going back down?
Well, first of all, it's great to see rates finally coming down. I think we've all been praying and hoping for that for some time, but it's starting to happen, which is good. I mean, I think it's kind of in two halves, right? If you have an existing project that you built before the rates went up, or indeed you contracted before the rates went up, then that's fine because you would have hedged your interest rates on your debt, and you will have fixed your supply prices and hedged any exposures that you might have there to things like metal prices and things like that. And you've probably got an index tariff or contract for difference, so you're protected in the market. So it's not a problem for existing projects. For new projects, it can be a problem. So that's why we saw the failure of the auction round in the UK, where no projects were able to bid in because the price was just too low. And that's really driven by material cost rises and interest rates. And we've also seen some projects here in the UK and also in the US actually stopped, or in a worst case, abandoned, because they cannot, keep the numbers low enough to make the project economic to build. So that really is a problem. So that's what we've seen. I think as interest rates come down, we'll start to see the cost of projects come down a bit. I don't think we'll get back to where we were 3 or 4 years ago, because things have in the world generally got more expensive. But we will see, the cost of the projects coming down, and therefore more projects starting to move out.
Before touching further on cost, you just mentioned index strike prices. So touching on subsidies and support schemes, which are very helpful at providing revenue certainty and de-risking investments. GB's contract for difference have proven quite successful at delivering wind historically. GB just had a new allocation round that procured 3.6 gigawatt of new offshore wind and 400 megawatt of floating offshore wind. You're developing projects globally. So how does the GB CFD scheme compare to other subsidy schemes? and what makes it attractive to developers?
Yeah, I mean, I think we have a project. We have a couple of projects in Scotland, which would, in theory, when they're ready, benefit from the UK scheme. We think it's a great scheme, as you say. Yeah, it delivers price certainty, enables you to raise debt and go ahead and build your project. So it's great for the deployment. The other thing about it is it's a competitive process. So actually, it's also good for the consumer because it gives that competitive tension, which forces us as developers to be efficient in what we do, so that we have a competitive bid and we're able to secure the CFD. So I think it's a really good system, and we do see it in lots of other markets around the world. And I think it is, the best way of deploying large volumes of offshore wind is for that government in that jurisdiction to offer a CFD scheme, for sure.
And in a context where those government scheme would get reduced or even completely disappear, as most governments around the world are now trying to cut their spending, PPAs are increasingly another route to market considered for projects. You've mentioned that some of your projects were backed by a PPA. Is this something that you're exploring increasingly? And is this like a must-have for projects now?
It's just one of the tools that exists, right? So, in some markets, let's take Germany right now, there isn't a tariff on offer, and there are projects coming up for auction. So if you want to look at those, you need to get yourself comfortable with power purchase agreements with third-party companies to get paid for your power. So it's possible. We do it. We have, in our Taiwanese project, we have a PPA as well as a subsidy. And in our German project, particularly the North Sea 1 project, the tariff will come to an end in the next few years, and we'll move into PPAs for that project. So we're very capable of doing that. They're slightly different to tariff. I mean, they're sort of, you don't really have to think too hard about credit when you're trading with the government. You can be pretty sure that they've got a good enough credit rating for you. Obviously, with commercial customers, you need to think about that. And sometimes the PPA, the length of the PPA may not be as long as you'd like. It may only be 5 or 10 years, whereas you may prefer a longer period. Certainly some tariffs or CFDs in the past have been 20 years. So you want as much price certainty for as long as you can. So it's a different game. And of course, you may have not just one PPA for the whole project. You may have a whole range of PPAs with different counterparties to spread your risk. And also some counterparties will want to do a contract for a few years. Others might be more open to doing a longer term PPA because it basically matches their business. If they built a new factory or a new industrial plant, they want power for the life of that asset. They're happy to transact for those longer periods. So it's a different skill. It's one that we have. And I think, you need to be able to play in both markets, I think, to be successful in offshore wind, because over time, if you look at some of the early projects that I've been involved in, they are coming to the end of their tariff period, their CFD period, and then they will be what we call merchant, so exposed to the market price. And you can, of course, sit there and be a price taker. I'm not sure anybody would feel too comfortable with them because of the volatility in prices. But you might wish to go out and get some PPAs. So I think we're all going to end up with some PPAs eventually. So the sooner we get comfortable and fluent in those, the better.
And we've talked about the sort of admin side of things so far. I'd like to explore a bit what's needed in the background to be ready to build such large projects. Each project relies on the readiness of an entire supply chain. Could you highlight what is critical to you when you assess the viability of a specific project?
I mean, you're absolutely right that there's a lot that needs to line up for a project to be successful and hit that sort of financial investment decision. And you have to really sort of look at what do you need to deliver this? And it starts really with the turbine. So the turbine is 50% of your capital costs. And then it's most of your operating costs through the life of the asset is maintaining that turbine. So that's the really big one that you need to line up. And of course, you've got to choose which one, how big it is, and then you need to negotiate how much you're going to pay for it. So I think getting ready for construction, the turbines is important. It also dictates, how big your foundation needs to be. It dictates how powerful your grid system needs to be, because all of it ultimately is driven from the turbine itself. And of course, the number one thing the turbine does is it generates electricity, and you predict that based on its power curve. So in other words, how much power does it generate versus wind speed? And then you turn that into money and say, well, how many kilowatt hours is that, and how much do I get paid? So the turbine really is the center, the central nucleus, if you like, of the project. So you have to get all that, and then once you've done that, then you get into things like, well, I need to design a foundation, I need to build a foundation, and I need to install the foundation. So then I get into foundation supply, foundation installation, and also the electrical system as well. So you have these big kind of building blocks that you have to design, and then you have to go and procure with the supply chain. Now, once you've done that, and you need quite a big project team, probably 200 people for one of these big projects to manage the complexity that you've got, you then need to bring all of those people, and it might be thousands of people, and it's certainly millions of man hours to build the project together in a coordinated way to get the project built on time and on budget. It's no small feat.
And so thinking about the manufacturing capabilities, we've seen CapEx hikes leading to developers retreating from the offshore wind market in recent years, especially just after the pandemic. How did that period affect the market? And is this now over, or are we still feeling the pain from that moment?
I mean, there's still some growing pains out there. I don't think we're fully through it. I think what we are seeing is investment in capacity in the supply chain. So we're seeing, for example, new foundation rolling facilities, monopole rolling facilities in Europe starting up. We've seen that in the last few weeks and in the last few years. We're also seeing big investments in vessels. So these jack-up vessels, which are the ones with legs that stand out of the water to install the turbines. One of the biggest companies, Tadler, is building 6 new ones, right? And each one of these costs about $500 million. So they're making enormous investments to bring the capacity that's needed into the system. So we are seeing some positives. Again, cable manufacturing is constrained, and we're seeing factories being extended and new ones being built. So it's coming. It's not there yet. I think the challenging part of the market really is the turbine. Famously in the press, there's been some problems. GE has had problems with blade issues in the US and here in the UK. Siemens, not with its offshore turbine, but with its onshore turbine, has had some challenges. And there's only, and then there's only Vestas as well, right? So in the market, really just 3 suppliers today. And they've only got so many factories, but they've got a lot of orders. Their order backlogs are staggering in terms of size and number of units that they've got to produce. And they've got a limited number of factories. Factories are really expensive for them to build. So they've got those challenges to face as well. So I think generally, capacity issues in the supply chain are being resolved, with the exception of turbine. We can talk about Chinese turbine supply in a moment. And I think then, unfortunately, behind that, you've still got raw materials prices, which globally are higher than they were 3-4 years ago, which, whilst there's been some improvement, are still pretty high. So I don't think those costs are going to go away. Certainly, labor costs have risen significantly since the pandemic, and I don't think that's going to go in the other direction. Certainly, given the growth in people that we need in the industry, I suspect they will stay where they are or go up. So I think those kind of costs are with us, are here to stay. Some of the other things will reduce over time.
We just want to touch down on what you mentioned around like Chinese turbine manufacturers. How much of a threat is that to European manufacturers, and what could Europe do to be competitive?
So it's a question that's been around the industry for quite some time. Look, China is the biggest market for offshore wind in the world, and they have some of the biggest turbines, or the biggest turbines in the world. Dongfang has installed an 18 megawatt this June, which is a huge wind turbine. They're now claiming that they've made an sale for a 26 megawatt machine. Now that hasn't been installed yet, and we have yet to see the blades being made for that. But that's a huge machine. So they have a huge installed capacity. They have a number of different suppliers, whether it's Mingyang, Dongfang, that are out there at the moment making offshore turbines and making big ones. And the expectation is, we don't know until we try, but the expectation is they will be materially cheaper than what we currently pay today. Now, that has to be proved out as a concept. But if you stand back from it and look at the market, if you look at the growth that's required to achieve the decarbonisation targets in Europe and North America, as an example, indeed around the world, we need a tremendous number of offshore wind turbines if offshore plays the role that we expect it to. So actually, we need more supply than we have today. We need Chinese supply in the market to deliver the number of projects that we're expected to deliver. So I think it's not a kind of either or choice. It's a together choice. I think that, there will be characteristics that mean a Siemens turbine is better in some applications than somebody else's, and there may be other applications where the Chinese turbine might make more sense because it has different characteristics, because they're not all the same. So I think for those reasons, I don't believe that it's going to be a market that shifts entirely to Chinese supply. I think there's a role for everybody. Of course, the European suppliers will need to be competitive in that process, but obviously we need the capacity that they currently have as well. So I think I'm optimistic that we'll find a path in the future that involves both.
And we've talked a lot about fixed bottom offshore wind, and I'm only going to ask one question around that, but is floating offshore wind the next frontier? Is that the way to go for the offshore wind industry from now on?
So I've been involved in a floating project in the Mediterranean called Provence Grand Large. It's a 3-turbine site with Siemens 8 megawatt turbines on it. And as a project person and an engineer, I would love floating to be the next frontier. I think in reality, though, I think the excitement of a few years ago has kind of cooled a bit with floating, and where we saw, or we hoped for, the deployment of floating on a large scale towards the end of this decade. I think it's probably now more likely in the early to mid 2030s. I think floating is just at a point where there's been a few what I would call demonstration projects, a bit like the one I worked on in France, but also, Hywind Scotland, Hywind Tampa, these projects that have been built, and a few others. There's been a few of those, but what we need to see is the next generation of what I would call kind of pre-commercial projects. So that's 300-400 megawatt style projects, really to allow developers and the supply chain to really test out the technology, the manufacturing techniques, the installation techniques at a scale that's kind of meaningful. And then you get really good empirical data on cost, installation cycle times, and all the things that you need to be confident about if you're going to do a big, gigawatt scale floating project. So I think we're kind of just waiting for that to happen now. There is obviously, as you mentioned at the beginning, CFDs have been awarded in the UK for floating projects of that scale. In France, the Brittany project, 350 megawatt project, has now been awarded. We obviously need to see those built, and that will take some time, but that's the next step. And then if they can do that successfully and find a pathway to develop and improve that makes floating competitive with other forms of generation, including fixed offshore wind, then I think it will become what I describe as one of the prime movers. So one of the things that we're deploying at scale to meet the needs of the market.
This has been a fascinating discussion. We've only scratched the surface of the topic, but extremely useful, and hopefully this provides a good whistle-stop tour of what's needed to deliver offshore wind. Do you have any closing remarks, Toby?
Yeah, I mean, in summary, I've had a great time so far, and I hope to continue for a long time more in offshore wind. But I think really, and some of the things we've touched on today, I would set out as the sort of the three key things that offshore wind needs to focus on in the future. I think the first we've discussed heavily is the supply chain. Getting what's needed at the right cost, at the right time, and at the right quality is really important for offshore wind to be successful and keep it attractive. It needs to deliver attractive or acceptable returns, particularly given the risks that you take when you try and actually build one of these things because of the complexity and the challenges. And I think, the continuation of things like CFD rounds, are really helpful in that, and they help us achieve our goals as a company, as Northland, but also as an industry and society to decarbonize. And really the third thing, the big call out I always make is around people. We need to have the people to build and operate these projects and work to develop the technology in the future. We need to find another 2 million people already, and that number will only get bigger as the market develops. So it's really, the secret to success in delivering a green future for renewables involving offshore wind is really the people who are actually going to do that for us. So I think finding, training, and developing those people is absolutely key to success. I think the great thing for Northland is that we are well progressed in all of those challenges around our people, around understanding and protecting, developing returns, and also working with the supply chain. We're in construction of 2 gigawatts, almost opposite sides of the globe. So we really understand the global supply chain and how to deliver that. We do have a floating project in Scotland that we're developing, and we'd like to see that come forward in the future. And we look forward to all of our other opportunities in offshore.
Toby, this brings us to the end of the podcast. I'd like to thank you very much for making the time to join us. It's been a real pleasure and a most insightful conversation.
Thanks very much.
That was Marc Hedin, Head of Research for UK and Ireland at Aurora, talking to Toby Edmonds, Executive Vice President for Offshore Renewables at Northland Power. Thanks for listening to Energy Unplugged. Do keep an eye on our podcast feed for more in-depth conversations with senior members of the energy industry. The best way to do this is to follow or subscribe to the podcast via whatever platform you use.